I'm Antoni Kędracki. I'm the lead iOS developer at Portdia, and I'm here today to tell you a little bit about Bluetooth Low Energy. So, a little bit shortcut of the presentation. Why Bluetooth Low Energy is so important? Why was it created? How does it work? And yeah, why should you care? So first start with a little fact. As Sheldon says, everything is better with Bluetooth, but it's not that simple. So let's start with some history. It's 1994, and there is this new idea. Let's connect everything with everything, especially connect everything that is around a person. So before, networks were based around network gear. You had servers, you had routers, you had all kinds of stuff. And this idea is, let's connect the devices around a person with its owner. So this is the personal area network idea. A very revolutionary idea at the time was that let's base it on a common radio interface and then allow other services to build on top of that. You must remember it was 20 years ago, so it was revolutionary at that time. So they did it. They created something like that. So the company responsible is called Ericsson. And let's have a look. Just 2 notes. First of all, I have a degree in telecommunication technology, so I am far more interested. I think I am far more interested in this kind of stuff than you are. So if I start to bore you guys, please give me a note. Secondly, if you have any questions, feel free to interrupt me at all times. Okay? Good. So the classic Bluetooth stack. As I think you have seen something like that before. It has a typical build. You have the radio, then you have something like a link manager, then something that is doing its job, no matter what. The 2 important parts in this diagram are this. First of all, SDP, which is Service Discovery Protocol, which is actually the protocol that is responsible for finding devices in the proximity of each other, so that 2 devices can find each other. And RFCOM is, let's say, real communication protocol, which simply allows sending bits through the radio. So that's it. So it's more like serial port. And all the other services are built on top of it. Okay. So 15 years later, the situation looks like this. The whole idea of Internet of Things, so the name has changed, but the idea is the same. It's still hot. It's hotter than before, but Bluetooth itself isn't doing a good job at it. So, the core idea of Bluetooth, that it should be low cost and low energy, is not really actually, they didn't made it. Actually, Wi-Fi, the normal Wi-Fi protocol, is beginning to get even cheaper than it was before, and So for some reasons, the guys at Bluetooth decide if we don't change something, we will lose the game. So they did something radical. Starting with Bluetooth Low Energy, so Bluetooth 4.0, they created 2 main configurations for Bluetooth. The first one is called Basic Extended Bitrate. This is actually the old one, the classic one. It has more bound rate and has a higher bandwidth, but is more power inefficient. And then you have this low energy one. The main idea with this is reduce power, reduce cost of implementation, at all other costs. So that's the primary idea. And they made a lot. So to present you a little bit of what is now possible with Bluetooth Low Energy, this is a little table. First of all, we have this is called BLE 112 module from BlueGiga. This is a Bluetooth Low Energy module. It has a max size of 80 millimeters, a weight of 2 grams, and at its peak power consumption, it takes 27 milliamperes of power. But it doesn't send the whole time, so it's very sporadic at this level. And then you have this very common tier to 20 to 32 battery coin, which has a very similar size, weighs 3 grams, and has 225 milliampere hours. So, basic math, if we would send the whole time, we would be able to send for 10 hours straight. As we are not sending the whole time, it's like more 1% of time, we can go for 10,000 hours, which will be huge. So, that's the math. A second part is what supports it, and that's, I will talk a little bit about it later on, but that's the most important part. Most iOS devices, and most Apple devices starting with 2012. So that's a lot. Some Android devices, but we will get to it later. So, that's the stack. Some of you may notice it's actually the same, is it? It is, with some very minor changes. So for example, you have this low energy radio, in comparison to this old war radio. These two parts are mostly the same, but the whole top is completely different. First of all, we have gap, which replaces SDP. So again, something that allows us to search for devices in the proximity. And we have a completely new base protocol for communication. We will get to this in a moment. One more note here. Some of you have noticed most of the components on the left and the right are the same. So why not make a device that supports both old or classic Bluetooth and the new smart version? You can do that actually. And if you consider that this part is made in hardware and this part is mostly done in software, then the cost of making a full-fledged Bluetooth module that supports both old Bluetooth and new Bluetooth is very low. But again, if you want to make a Bluetooth LE only device, it's a lot cheaper than a full-blown implementation. So let's get to the basic idea. Any questions? No. Good. So GATT. I want to tell you what the acronym is. Sorry, I forgot. There are like 50,000 acronyms there, but the very important thing is that the new stuff that you should use when implementing anything on Bluetooth. So the classic one was built like this. You had devices which were more or less same, the same, like they have the same role. They simply you were able to connect to them, and then when you connected to them, you had the option to send raw bytes through a pipe. Nice, flexible, but a little bit hard to implement on your side because you need to take care of message synchronization, checksums, and so on and so on. And the guys at Bluetooth decided to slim it down a little bit. So first of all, they introduced a separation of roles. This separation is like this: one device which serves data, which is for example, a sensor or a health instrument or something like that. Something that serves data is the server. It has its own role, and there is a client, the one that consumes this data. Also, a change is that they don't communicate with raw byte streams. They communicate with a model, actually you can consider it a key value store that is provided by the server and consumed by the client. And this key value store is actually a little bit on steroids. It's it has services, so it has these keys and values. These are characteristics. Then it has characteristics which put a lot of characteristics together in one service, and then you have descriptors that are metadata to these characteristics. So, and also a very important thing, everything has a UID, a 16-byte or a 128-byte one. So, how does a service look like? Something like that. This example service, it's from a group that is known as well-known services, so the ones that are predefined by the Bluetooth guys. It has an identifier and 3 characteristics. we are mostly interested in this one, heart rate measurement, characteristic. Also note that characteristic can have one of three attributes, or actually any combination of three attributes. They can be read, they can be written, and they can be notified. So you can subscribe for notifications, which looks like this. I, as a like for example, my heart. Let's say that's my heart, but I had some problems. That's my iPhone. It subscribes to the characteristics of my body measurement, and every time the sensor is ready to deliver a new reading, it will send it to me. I don't have to ask every time, so I don't have to pull. And this is very important, but because again we are sparing on energy, so we are more energy efficient about this. Okay, enough of the talk. Let's have a demo. Okay, so I see we have some SD modes in the proximity.
Excuse me, I have one question.
Yeah.
Is it possible to subscribe more to one device
No.
than one? Okay.
We'll talk about it later, but yes, that's a very good question. In the specification, it is directly noted. Only one client can connect one server at a time.
Okay.
And there are some rules around it, but let's say that's the basic idea. Okay, so this is a heart rate monitor. I need to connect to myself, so sorry for touching myself. One moment. Yeah, sorry. As you can see, there is a Polar H7 heart rate monitor in here, so I can connect it. So this device, by the way, this application, this is called Light Blue. It's actually a debug application for all the stuff you would like to know about devices. So if I connect to this device, I can see the services provided by this particular device. I am mostly interested in something that is called 180D, so this is the heart rate measurement service. And then there is this 2837 characteristic, which provides me with the information about the current measurement. As you can see, it can be subscribed to. I will do that. And hopefully, it will start providing me with information about my heart rate. It's a little bit coded, but if you look at this 75, oh my god. 73 in hex, this is something like 100 something. So yeah, my heart is now rising, like a lot, but this is all specified. As you can see, I subscribed once, and now I only get like information about this. How to decode this one? There is of course, a specification for that. So, as said before, this heart rate monitor is from a group that is known as well-known devices. Well-known devices have a specification. Sorry for the small font here down here, but the presentation will be available later. You can check it out, and actually I will click it on it. Or not. Good. Trust me on my word. There is a whole specification around this service, how it's built, and actually how the data is packed into the characteristic. Because from the specification point of view, the characteristic is simply a number of bytes, and all the details how each service packs or each characteristic is packed with data is actually up to the specification for a particular one. For heart rate measurement, it's like this. The first byte is filled with flags, which say, for example, if later on the data is stored with 8 bits or 16 bits accuracy. So you saw that there was 16, so this is the first format. So 8 bytes for heart rate volume. Yeah, and that's all. more thing that you had saw and maybe not. If you notice is that in the service part there are other services. I cannot remember which one, but one of them is, for example, the battery service. There is a predefined service that says, okay, this device has a battery, this battery is 80% full or not. I can't remember which one. And this particular one is, these are called vendor characteristics. These are characteristics that are defined by the vendors for their own purpose. They have a very long UID so that to prevent any conflicts, but they are here. So theoretically, if I would contact Polar and ask them, maybe they would tell me what this means, or maybe not. Yeah. Okay. Let's go on. A very important note. We had this in one of our projects. Bluetooth Low Energy doesn't support serial port communication. Why I tell you this? Because if you start working with Bluetooth Low Energies, at some point you will start working with persons that are more connected to hardware, and you must know hardware engineers love serial ports. Why? Because they are easy to use and everything has a serial port. So they are used to that all Bluetooth has a serial port communication, and they cannot accept the fact that the new one doesn't do this. And they try to make some hacks on characteristic to emulate a port. Doesn't work that well. Yeah, but that's only a note. That's about GAT. Now let's talk about the radio. Again, some telecommunication stuff that most people won't bother you, but you must know a little bit. First of all, Bluetooth runs on the same band that all the popular network communication protocols work. That is Wi-Fi, Zigbee, and so on and so on. This 2.4 GHz band. This means for us that everything on this band interrupts everything else or interferes with everything else. And each of these technology has a different approach to how to work. Bluetooth in this case has a very interesting one. I will skip you the details, but what you must know for Bluetooth Low Energy is that the implementation was reduced drastically. In the classical one, there is some space in the specification. This has 40 pages. For the new one, it has only 1 page. So 40 rate the reduction of complexity, which also means far less parts. Next part, advertisement, which is far more interesting for us. Again, everything Bluetooth Low Energy is optimized for power, but they introduced something new, which is called passive scanning and active scanning. That's the first change, and the second change is the introduction of flexible advertisement data. We'll come to that. That's not important. So, passive scanning, which is hugely important. As said, before it was like this, that devices were more symmetric in their function in the network. So each device, when it was enabled, do it like this. It spent some time on a channel. It said, "Okay, I am here." In the same time, it searched for the other devices in the proximity and they handled them properly. The problem is, if no other devices were there, then this device, the scanning device, would waste a lot of energy. It will work for months and it will only lose energy. And as with Bluetooth Low Energy, we have this differentiation between server and client side. We can now have passive scanning. So the server on the right side, let's say heart rate monitor, advertises with some data to the network, and an interested client only listens. So it doesn't consume any power, or more or less no power. Which is nice, because if it sees some devices, it can simply connect to them. If not, if it's not interested. The second part, which is also very important, is that in this advertisement data, this device completely describes what it does, or what type of data it provides to the client. So the client doesn't need to bother with devices that are not it's not interested in. For example, for this heart rate monitor, it will only listen for this heart rate monitor devices if an application that say it as a sport tracker is interested in this kind of devices and it wants to connect to them. So that was passive scanning, very huge improvement, but has a very small drawback. That is, the advertisement data is very small. So for this purpose, there is this active scanning, which is more reminiscent to the old version. That is, if a client sees something interesting, it can say, oh, I am interested, say me some more. And it will get some, like, as a second amount of data which can be received before. So that's pretty nice. On the other hand, if it already got this data, it can say, oh, no, I'm not really interested, I will simply skip it over for the future. So, what can be in the pockets, in the advertisement data pockets? That's a very nice change again, because in the old Bluetooth we had completely no control over it. And in the new Bluetooth one, we have I would say we can do almost everything. The idea is that each advertisement data has up to 31 bytes of data, and we can these bytes are filled with AD structures. Each structure is composed of length, advertisement data type, and some data. Easy, isn't it? And you can like append a lot of these structures as long as you have space left. So, for example, what can be placed in this advertisement data? This is something that probably this device is sending. This heart rate monitor is sending. It says, okay, I have some flags. These are not very important for us, but they are very important for the protocol. But it will, for example, send this type 3 advertisement data structure of length 9, which says, okay, I am a heart rate monitor. With help of that, a device like an iPhone can say, okay, I'm interested in this device. And also, what it can also send in this 31 bytes, because we have some space left, it can send a type 9 structure, which is a local name one, which means a local name, and said, okay, this is the heart rate monitor of Antoni. So if there are more than one device in the proximity, based on that we can say, okay, this is mine and not Kasia. Yeah? Good. Questions? Yeah. So the very important part about the active scanning is that you can put the second amount of data when doing active scanning. So we had already the situation that we could not fit into one pocket, so we needed to this active scanning to work, to put more stuff into the service. Good. A second thing that is more also a nice hack on top of Bluetooth Low Energy is this whole iBeacon ones. I think all of you heard of iBeacons. Somebody didn't hear about iBeacons? No. Estimate? Yeah. So Estimate is based on that one. The whole idea is they use this FF, so 255 type advertisement data structure, which is reserved for like vendor stuff. According to the specification, there is only one rule. If you use FF, you need to place your vendor ID just after it, and everything else is up to you what do you want to place. So what Apple did is to place simply this one, which is I don't know, but I really know what this is. These are the beacon UID. So this is called, they actually call it beacon ID, UID I think, and the major and the minor number. So that's one important part. So what the iPhone system does is it simply, when it sees a device that advertises this kind of structure, it sees these three numbers and says, is anybody interested in this particular beacon or not? If yes, it sends it to the application. Again, no participation on the part of the iPhone. It's completely passive. So, yeah, no battery consumption. What it also does is, somewhere in here, there is the value of the something that's called transmit power. So the power that the device is transmitting its signal. And then if we compare this with the read power, so the power that we have read the signal, we can estimate the distance between the two devices. There is actually an equation for that. Yeah, so that's all for 5 minutes. Questions? Okay. This is far more interesting thing for the developers because it mimics something that we will do in code. If we have some time, I will try to show you some code, but let's see. So what we need to do when we connect? First of all, we need to scan. We need to find a device that is available for us. If we find one, we want to connect to this. You would think, okay, that's all. Not right. Then we need to discover the services that it provides. Then, if we have the services, we need to scan for characteristics it provides. And then we are finally ready. You may ask you, why could we not take the easy step? So if we know by means of the advertisement data that a device supports some characteristic that we are interested in, why bother? And why do this whole thing? There are two reasons. First of all, only by the service UID, it doesn't tell you a lot. According to the specification, if a service is even well defined, it can have optional characteristics or optional fields in the characteristics. So by doing this whole part, you're actually checking what kind or to what extent you are supporting this particular service or not. So that's the thing. And there is a second reason. As said before, every characteristic and every service has a UID, which is 128 bits or 16 bits. If you consider that a pocket, like this thing that is sent through the radio, has 21 by standard, 21 or 24 bytes, and you put 16 bytes of addressing data in each pocket, you lose a lot of space. So instead of doing this, during this discovery, we exchanged every UID with a 2-byte couple. So that's the reason why it's supported. Yeah. Very nice information for the Android guys. Android does this whole procedure for you. iOS doesn't. So you need to you have asynchronous hell because you get one delegate, then it sends you some callbacks. Then you need to call another function. It sends some callbacks. Another function it sends some callbacks, and then you are ready. I will show you that. So Android did it better this time. Security. Yeah, so first of all, no security at all. Who bothers? Yeah, that's not. One could say that the value of my heart rate at the time is not very important. I could argue with that argument, but let's say it's not that important. By default, all the security features of Bluetooth Low Energy are disabled. If you want to enable them, there are some ways, but it's optional. So you can enable something that is called pairing or encrypted or secured, depending on the place in the documentation, which is based on ES, pretty standard one, I would say. The important part is that's up to the client device, which is called master this time, but that's the way with the documentation. So it's up to the client, my iPhone, to decide if it wants to use secure connection or not. If he wants, it actually starts the whole pairing process, which at the end results in some keys that are used by the devices to encrypt data. There are 3 methods of authentication. Just works. So, yeah, we are here. We want to connect. Let's connect. No out of bound or no secret between the devices. So it's very easy to sniff around it. There is this passkey option where you input six sites, which is a little bit better. And there is this out-of-bound communication, so you simply need to provide, by different means, the whole key to participating devices, which is mostly secure. Yeah, but it's very, very, very sensitive to eavesdropping. So if 2 devices pair, and a third party sniffs on the radio at this time, it is able to reproduce the whole process without any problems. Which wouldn't be that bad if not for a very funny mechanism built into Bluetooth. So there is this way for one device to say the other device, sorry, we were paired before, but we would like to pair, I forgot the keys, let's pair another time. So the only thing that a third party needs to do if he wants to sniff on the keys is to send, pretend it's one of the devices and send it the proper key to the second device. And then he gets the opportunity to eavesdrop again. So weak. Another problem is this passkey thing. 6 digits, that's something like 10 bits of entropy, not that strong. So, all if you really are concerned about security, you have two options. You can use the OOP version, so you simply can provide the keys out of bound, or you can encrypt in the application layer. Up to you. So, for you, not really secure. Questions? No. So, why it's so important? As mentioned before, everything starting with 2012 has, from Apple, has Bluetooth Low Energy support. Which means, for the first time ever, one can create accessories for iPhone, or connected accessories to for an iPhone or for an iOS device that don't need NFI certification. Which means that every of you can start doing some hardware for the iPhone and some everything what you want. Which is huge because before you had to go through a very long certification process and pay something like $10,000, which if I remember right. Yeah, so that's nice. Second part is that Android did some little fail. That is, starting with the same, in the same time, Android devices started to have support, hardware support for Bluetooth Low Energy. But the very important API for that was released 2013, actually July. So I did play to the game. And yeah, I will stop commenting on that one. The very important thing is, as again said, iOS, accessories, everyone wants to do accessories. So we have all kind of stuff. Armbands for health or fitness measuring. How many of you have a Fitbit? Heads up. Fitbits, Nike Pluses, any kind of this. Yeah. I'm disappointed. We have 4 at the company right now. So, but we have different kinds, heart rate monitors. I have this one. We have parts like a Dice Plus. Anybody knows what a Dice Plus is? Better. So for all the other guys, it's actually a dice that has Bluetooth Low Energy enabled. So when you throw it, it sends the result of the throw to the application. So you can have really nice board games. I have some dice with me, so I can show you later. Yeah, tokens, smartwatches, whatever you want. And there are unlocking solutions for homes and so on and so on. Good. That will be mostly all. If you have problems sleeping, I would recommend you this fine lecture. It is the specification for the Bluetooth stack. It has only 2,500 pages. Very nice read. And I also thank the guys from the NAND project for providing some icons. Yeah. Questions? Okay. That went well. Do you want a small code demo or not? Yes?
Yes.
Okay. I have 15 minutes, that would be really good. Something is not right here.
is also official, and we can read the tags.
Do you want? Okay, let's try. That's small. Or no. Let's disable all of stuff. Yay. I think not. The question is, can you read it? From the back. Not really.
Use AppCode.
Very good idea. It's a very good idea. Okay. Much more better. Visible from the back? Good. So, I have this application, which is very simple. It only displays my health rate. Oh my god. Yeah, so that's all from the application voice. What you must know. So, first of all, the framework responsible for Bluetooth on iOS, this is called Core Bluetooth. So what you will need is the TBUID instances of the services and the characteristics you are interested in, because you will use them. There is, of course, an object for that, and you create it with UID string. Remember, 18.0D, which is the current service, and 2A37, which is the heart rate monitor stuff. The second thing that you will need definitely is the central manager. This is the main object that manages the core Bluetooth stack. And you need to provide a delegate for it. And very important part, finally, Apple started to think about this kind of stuff, and this is the, I think, third or fourth framework that supports providing a queue to the constructor that it will be used for providing all the callbacks, which is very nice. It wasn't here before for other frameworks. So, what will happen now is that the central manager will inform us that it is in a state. So, for example, it can be powered down, it can be disabled, or the application may have been disallowed to access it. Like any other contacts, calendars, and all kind of these things, you have control for. You don't have direct control over it from the application. If it's not available for you, you need to inform the user about, please enable Bluetooth and please give me permissions to use it. The very important part for us, power it on, so this is the case when it works. So, if you have this one, you can start scanning. So you go to this very nice scan for peripherals with services. And you have two options. You can provide nil, which means I am interested in all kinds of devices. And you can provide an array of service UIDs you are interested in, which will mean that iOS will only inform you about these devices that you are particularly interested in. It has some other implications, like if you provide nil, it will not work in the background. And if you provide a concrete service, it will work more or less in the background. Okay, so we now said we want services. So at some point in time when we discover something, we did discover peripheral. We would normally say, okay, if this is my peripheral, we would present a list to the users. But in this case, it's very simple. I say, okay, first hereditary monitor, I grab it. So I grab it, and I send connect peripheral, which means that at some point I will say, get what either did connect peripheral, or did disconnect the peripheral, or did fail to connect peripheral. Yeah? Let's say we were lucky, so did connect the peripheral. Again, I need to ask for services. And I can again provide the services that I am interested in. It's familiar. Yeah? I can provide again new to get all of them. So now I will get an undefined amount of callbacks on did discover service, which really is problematic because there is no way saying, okay, you're ready, you have all the services. It will simply send you 2, 10, 3, 1. It depends on the wind direction at this moment, which is really problematic. If you want to really say, okay, I'm ready, you can't. I would say 5 seconds is more or less okay. We have no way for now. So we have services. Let's find the characteristics for them. So we need to search for it. And then finally we have did discover characteristics. We are almost ready. I also said notify on this characteristic that I'm interested in, so this characteristics. And starting from now, every like time there is something new, I will get did update values for characteristics. Which means I can have some data in it, or I can read it from, I can read it from here, which is any data. But I can have a byte array. And a very important thing, I need to like unpack the data from the structure. You will see a lot of this function in this kind of code in your applications because it should be defined in the specification which byte ordering the Bluetooth LE uses or this particular service uses. You can assume it's with endian and you need to show it to host. Yeah. And some debug data, and that's all. Questions? Yeah?
So basically we are only interested in this characteristic 180D for arc measurement, or it's more like polar specifics?
No, this, so the question was, is this, oh my god, 180D characteristic or service, it's actually a service. Is it polar specific? No, this is a generic profile for all the characteristic monitors available on the market, which, of course, only if they support this profile. But most of them do because then they get integration with, for example, Endomondo, Runkeeper, different other apps for this purpose. Other questions? Nope. Then thank you very much.